Hello all, welcome to today's session. Today we are going to discuss the problem related to Kirchhoff's current law and voltage law. The question is, find current in 15 ohm resistor, voltage across 18 ohm resistor and power dissipated in 7 ohm resistor. This is a given circuit. For this given circuit we are supposed to find the current in 15 ohm resistor, voltage across 18 ohm resistor and power dissipated in 7 ohm resistor. For this given circuit we have to find the three values. So the circuit here, this two resistors, that 9 ohm and then 8 ohm, both are connected in parallel. So for that we can find the equivalent resistance. So 9 ohms and 18 ohms are connected in parallel. By using the formula R1 R2 divided by R1 plus R2, we are finding the total resistance. So we got 6 ohm. So the circuit is redrawn like this. See here, remaining all the resistors and all the values are not at all disturbed. We just change this 9 and 18 which are connected in parallel, and then we found the total resistance is a 6 ohm. So the circuit is like this. So here from this given circuit, this is a voltage source. In this voltage source, this is a plus terminal plus and this is minus. So again I am starting plus minus, the polarity I am giving for this circuit, and then here also plus minus, plus minus, plus minus, plus minus, like that I made it. So in loop 1, what I'm supposed to do, see here, I'm framing the equation from higher potential to lower potential. Higher potential, lower potential, as already we discussed. So it is a negative sign, and then this is V according to Kirchhoff's voltage law. This is V. V is equal to I into R. I is I1 and R is 4 ohm. So minus 4 I1 coming to this resistor, higher value to lower value. So minus 6 I1 here while coming in this loop, it is higher value to lower value. So minus, but it is in opposite direction. So for the direction is opposite, I am supposed to put one more minus. So minus 7. The current in this branch is I2. So please, I am repeating this. This is coming in this direction. Whenever it is coming in this direction, higher value to lower value, for that I am supposed to put minus. And then this is the current I2 in this branch is in opposite direction. Actually we are taking as anti-clockwise direction, clockwise direction, but this is in opposite direction. So I am putting minus 7 I2. Next minus, this is higher value to lower value, that is minus, but opposite direction. So minus of 2 I2, that is equal to 0. If you simplify, you'll get the equation minus 10 I1 plus 9 I2, that is equal to 0. I'm naming this equation 1. Now coming for the equation 2, see, this is your voltage source. This is from higher potential to lower potential to, it is coming in this direction. So lower potential to higher potential. So I am considering plus. From higher potential to lower potential, minus 5. Current in this branch as given in the question is I1 plus I2. So minus 15 I1 plus I2 minus, this is same direction. So higher value to lower value. So minus 2. Current in this is I2, minus 2 I2 minus, that is higher value to lower value. So minus 7 I2 is equal to 0. If you simplify this, we'll get minus 15 I1 minus 24 I2, that is equal to minus 125. Naming this equation 2. Now if you substitute this value in the equation in calculator, we will get I1 is equal to 3 amps and I2 is equal to 3.33 ampere. Next, so in this, the first question is current in 15 ohms. Current in 15 ohms is, as given in the question, is current in 15 ohm resistor is I1 plus I2. Just now we found I1 and I2. So if you add this, you will get 6.33 ampere. Then voltage across 18 ohm resistor. Using current divider rule, I4 is the current in the 18 ohm. So I4 is equal to, I1 is the total current for that branch. So I1 into 9 divided by 9 plus 18. So we'll get 3 into 9 by 9 plus 18. So I4 is equal to 1 ampere. Now voltage across 18 ohms is V is equal to IR. I is 4 I4 and then R is 18 ohm. So 1 into 18 you will get V at 18 ohm. That voltage at 18 ohms is 18 volt. Now power dissipated in 7 ohm resistor. P is equal to I square R. In that 7 ohm resistor the current flow is 3.33. So 3.33 square into 7. So we'll get P is equal to 77.62 watts. So problem number 2, the question is, for the given network, determine all the branch current and the voltage across 5 ohm resistor by mesh current method. This is the given question. So we are supposed to determine the all branch current and then voltage across 5 ohm resistor. Across this resistor we are supposed to find the voltage, and then we have to find the current in all branches by using the mesh current method. Same circuit diagram, I am just naming the current. This is I1 is just I am naming this branch current as I1, this is IB, and this is I am taking as a IC. So IC is equal to IA plus IB, IA plus IB, because this IA and IB are incoming current, and then IC is the outgoing current. So IC is equal to IA plus IB. Then in this loop 1, that is A, B, E, F, A. So in loop 1, see here, this is flowing from, it is a clockwise direction, it is flowing from lower value to higher value, so plus 50, and this is from higher value to lower value, so it is minus 3, and then current is I1, this is higher value to lower value, so it is minus 5, current in this branch is IC, minus this current higher value to lower value, this is moving lower value, so minus 6I1. So the equation will be like this. So if you simplify this, you will get minus 9IA minus 5IC is equal to minus 50. So here again I am taking minus as a common, so we will get 9IA plus 5IC is equal to 50. So now instead of IC, already I have seen IC is equal to IA plus IB. If you substitute that value, you will get the equation 14IA plus 5IB is equal to 50. Now in loop 2, see here, in loop 2 B, C, D, E, B, so here it is in anti-clockwise direction from lower value to higher value, so I am taking this as a plus 25, and then this is from higher value to lower value, so it is minus 2 IB, higher value to lower value, minus 5 IA plus IB. Instead of this is actually this is IC, instead of IC I'm making this as a IA plus IB, minus 8 IB is equal to 0. So if you substitute the value, we'll get, and then here I'm taking minus 5 as a common. So if I take minus 5 as a common, I'll get IA plus 3 IB is equal to 5. So finally, if you substitute this two value in calculator, IA is equal to 3.337 ampere and IB is equal to 0.54 ampere. Then the question they asked, voltage across the 5 ohm resistor. For 5 ohm resistor, voltage V is equal to I into R. So IC into R value is 5 ohm it is given. So instead of IC, IA plus IB. So if you substitute the value, you will get V across, that voltage across 5 ohm resistor is 19.55 volt. I hope this video is very useful for you. Subscribe, support and share. Thank you.